Number 10, find the magnitudes of the velocities VA and VB in figure 3.55. So the figure's over here on the right-hand side. So they want us to find the magnitude of this velocity, VA, and the magnitude of this velocity, VB. Okay, so let's take a look at what we're given. So we're given the total magnitude of the resultant vector, all right? And it gives us several angles in this figure. So since I know the resultant vector here, what I'm going to do is I'm going to try to create a triangle out of that resultant vector. All right. Basically what I'm looking to do is break it down into its components. So if this were, let's say, the hypotenuse of my triangle, all right, then this would be one of the legs, and this would be the other leg, right? So that forms a nice triangle. Now let me redraw that, all right, just so it's not so messy down below. So we got this, we got this. Let me extend this line a little more, and then that comes right down. Great. Now, I know that the side right here, right, is 67 or 6.72 meters per second. Okay. Do we know anything else about the triangle? Do we know any internal angles? Well, we do, right? We know this angle right here. Take a look at the figure. If I were to add 26.5 and 22.5, wouldn't that tell me the measure of this whole angle? Yeah, it would, right? So let's do that. So 26.5 plus 22.5 is equal to 49. So the angle in here is 49 degrees. Okay, now, knowing one of the sides and one of the angles, I can now solve for everything else within this right triangle. I can solve for every other side and any other angle. All right, so let's do that. Let's color code this. So why don't we put this side in red, and we'll call that the negative, not negative, positive x, right? Because it's in the positive x direction, right? Given where the coordinates are, and we'll call this the y. All right, and we'll give that a positive y value. Right, remember that the axis here, our coordinate system was dotted in here, right? So that should make sense. I'm in the positive x and the positive y. All right, so let's backtrack there. Okay, so now let's find the sides. So let's find the x component of the resultant vector. All right, so I'm going to do, so again, I want to find this side, and I know the hypotenuse and I know the angle that is adjacent to that side. Therefore, that sounds like a cosine function. So cosine of theta is equal to adjacent over hypotenuse. The cosine of 49 is equal to the positive x value over 6.72. Simply cross multiply. So make sure your calculator's in degree mode. Cosine of 49 times 6.72. And it comes out to 4.41. So the x value here is 4.41. And remember, this is the x component of the resultant vector. Okay, so that's my answer there. Now, how about solving for the y component of the resultant vector? Well, we know the hypotenuse, and we know we know an angle that is opposite of the side of interest. So that means, went back too far, that means we can use the sine function. Right, so the sine of theta is equal to opposite over hypotenuse. The sine of 49 is equal to the positive y value over 6.72. So now just simply cross multiply again. Sine of 49 times 6.72 comes out to 5.07. All right, great. So this is 5.07. And this, remember, is the y component of the resultant vector. All right, so we got that. Now, remember that looking back to the picture now on the upper right-hand side, let me erase. Now remember that this resultant vector here, this resultant vector is simply the summation of this vector and this vector. So what exactly does that mean? Well, that means that in order for me to find the components of the resultant vector, I can simply add up all the components of the two vectors that summed up to give me that resultant vector. So let's think about a component table. Okay, so let me put my component table here. So component, hold on, component table. Okay, I have my X components in the problem and I have my Y components. And I have three vectors. I have vector A, vector B, and the resultant vector. Now remember, when I add vector A's components to vector B's components, I get the components of the resultant. What did we just find? We just found the X component of the resultant vector and the Y component of the resultant vector. So we actually know these values here at the bottom of our table. So let's plug them in. So we have 4.41 and we have 5.07. And these are all in meters per second. I'm just going to leave out the units for now just to make things simpler. Okay, so now I'm missing these values, right? And now you might be thinking to yourself, well, man, this is going to be hard to calculate. What am I going to do? I can't see how to get to the answer. Don't worry. All right. Let's just start creating equations, solving for things, and let's see where it takes us. And then maybe after we start putting some stuff together, maybe the answer will pop out. Okay. So first, let's take a look at this. Let's first take a look at vector A over here in the picture on the right-hand side. Now, vector A, I want to find vector A's components. So how do I do that? Well, you always have to create your triangle. So here's the hypotenuse. Here would be the X component, and here would be the Y component. So let's take that triangle and let's draw it out here on the bottom of the page. So we got this, and we got that. Let's color code it. Let's put the X value in red, and let's put the Y value in yellow. Now, what do we know about this? Well, all I know is that this has a value of VA, right? I don't know how that turned into an O. This has a value of VA. That's all I know, okay, about the magnitude. I do know something, though, about this particular angle here. And this particular angle, I know that it is 22.5. How did I know that? Just look back at the picture. 22.5 is right in here. Okay, so now, so let me label this as my positive X component of vector A. And this is my positive Y component of vector B. Excuse me, positive Y component of vector A. So now how do I solve for the positive X component of vector A? Well, I would take the hypotenuse value, this angle, and then consider that this side is adjacent to the angle, so therefore I could use cosine, right? Now you might say, well, I don't know a value for this, so what the heck is that going to do for me? Don't worry, let's just do it. Let's solve for X, and we'll see where it gets us. So let's do cosine of theta is equal to adjacent over hypotenuse. So cosine of 22.5 is equal to the positive X value, or X component, over VA. So that means my X component of vector A is equal to the velocity of A, the overall velocity of A, multiplied by cosine of 22.5. Okay, great. Now, that may not sound, satisfactory to you. It's not an answer, right? Because we don't know what this is, but what can we do with this value? Can we put this anywhere? Meaning, could we put it in our component table? Well, yeah, we actually could, right? We could put this in our component table. So let's go to the component table, find the X component, find VA, and now let's plug in our answer right here in the component table. So it was VA cosine of 22.5. Okay, Now let's do the same thing for the y component in this problem. Remember, hypotenuse, angle, and the side opposite of that angle, I'm going to be using sine. So sine of theta is equal to the positive y component over VA. So y is simply equal to VA sine of my angle, right? Which is 22.5. I usually write the formula out first, but I kind of did both at the same time. But this is sine of theta is equal to the opposite side over the hypotenuse. And then what I should have done here was plug in my, plug in my angle measure, right? So this was 22.5. Okay, so here's my y component for vector A. So let's plug that into my table right here. Okay, so we have VA sine of 22.5. Okay, great. Now, let's go back to our picture on the upper right-hand side. Let's clean it up. We took care of vector A. Now let's take care of vector B. So vector B is right here. Here's vector B. Let me draw it a little better. Here's vector B. Okay, now, how can I create a triangle from vector B? Well, we can do this in one of two ways, right? I mean, there's a couple of ways you can create the triangle. Why don't we do it this way? Let me create the triangle here and then bring this straight down. Let's create that triangle, okay? This side here would be the x component, this side here, and we notice that they're both positive, right? That's positive x and that's a positive y. Okay, but the problem here is when I create this triangle, do I know any of the angles? Well, I know that this is a right angle, but do I know this angle? No, I don't. Do I know? Uh-oh. I thought he was going to bum rush the room. Sorry. Do I know that angle? No, I don't know any angles in here, right? At least not right now. But can you think about a way to maybe solve for this angle in here? Well, this triangle that I just created is part of a bigger triangle, right? Watch this. This little triangle could be considered part of the big overall resultant triangle, right? Now, if you think about it, what was the angle in here of that big overall triangle? Remember, we said we would have had to have added the 26.5, and then that was 22.5. Right? So that overall angle, bottom left-hand side of the screen, we found to be 49. Right? So if I were to ask you, considering this triangle over here on the left-hand side, what would this angle be? Well, remember, all the angles in a triangle add up to 180. This angle in here is 90. So what I need to do is take 180 minus 90 minus 49. It gives me 41. So this angle in here is equal to 41 degrees. Now go back up to the picture on the upper right-hand side. So I know this whole measure in here. This whole measure is 41 degrees. If that whole measure is 41, and I know part of it is 23, can I find the other little missing piece in there? Yeah, we can, right? We can just do a subtraction. So why don't we do that? All right. So this is 41. Let me now erase some stuff in my picture on the upper right-hand corner. All right, just so we can make it a little more clear. All right, so what we'll do is we'll draw this triangle back in. Great, we got that here and here. Okay, and now remember, this whole angle in here was 41 degrees. So this little piece in here would simply be 41 minus the 23 degrees. Okay, cool. So let's do 41 minus 23. That gives us 18. So this little angle in there, let's backtrack a little bit. This little angle in here is 18 degrees. Okay, now we should have enough we need in order to help us now solve some of the components. All right. So what I'm going to do is take this triangle out and write it down below. So here we go. So we got this, and there. Okay. We know that this angle in here is 18 degrees. We also know that the value of the hypotenuse was VB. Okay? we need to now find the x component and the y component of this VB vector. So here's the x. That's a positive x. And here's the y. They're both positive. Let's first look at the x. How would I solve for this side of the triangle knowing that I have a hypotenuse and an angle that is opposite of the side? It would be sine, right? So let's do sine of theta is equal to opposite over hypotenuse. So the sine of 18 is going to be equal to positive x over VB. Now, the x component here of vector B is simply VB sine of 18. Okay, what can I do with this now? I can go to my table, locate the x component and the VB, and I can plug it in. So let's do that. So I have VB sine of 18. Okay. One more step. Let's do it now for the y. For y here, I would be using cosine because this angle is adjacent to that side. So let's do it below here. So we have cosine of theta is equal to adjacent over hypotenuse. So cosine of 18 would be equal to the positive y value over VB. So the y value here is going to be equal to VB times cosine of 18. What can I do with this value now? I can go to my component table and plug it in right there. Great. So let's do that. So we got VB times cosine of 18. All right. Now, you guys see where to take it from here? Maybe? Well, let me write it out now. Remember that in my component table, the resultant vector is simply the addition of vector A and vector B's components. So I can write out two equations here. I can write out an equation for my x components and my y components. Follow me on the upper left-hand corner. So the resultant vector's x component should equal the vector A's x component plus vector B's x component, right? I'm just simply looking at this particular column of my table. Okay. And same thing here. I can take now my resultant y component and say that it should be the VA y component plus the VB y component. All right. So now, why don't we start substituting the numbers in? So let's do that. So the x component of the resultant was 4.41, and that should equal now VA cosine of 22.5, right, plus VB sine of 18. Same thing now with the y. I got 5.07 is equal to VA sine, right, of 22.5 plus VB cosine of 18. Let me make that a little neater. Cosine of 18. Okay. Now guess what, guys? Look at this. This goes back to high school. Now, algebra. I have two equations. How many unknowns? I have two unknowns, VA and VB. How do we solve? It's a system of equations problem. We just have to solve one of these for we just have to solve one equation for one variable and then take it in and substitute it in for the other. Right? That's all we have to do. So it doesn't matter to me which one we solve for. Why don't we, I'm running out of space a little bit, so why don't we take this equation and solve it for, I don't know, VA, right? So remember, you'd have to subtract this side on over and then divide the whole thing by cosine of 22.5. Okay? So the result would be, let me just write the result here. Try to do it in my head quickly. So the result would be VA, hopefully I don't make a mistake. VA is going to equal 4.41 minus VB sine of 18. Okay, then divided by cosine of 22.5. Now what I can do with this result is I can take it and now plug it in my second equation. All right, so let me write that out now. So I'm going to rewrite this equation now. So let's do 5.07 is equal to VA. So let's write it all out. So I'm going to put it in red. So 4.41 minus VB sine of 18 divided by cosine of 22.5. And that would now be multiplied, right? This whole thing, because that's VA, that whole thing's multiplied by sine of 22.5. And now plus VB cosine of 18. All right, cool. So now, now I have one equation with only one unknown. All I got to do is now basic algebra to solve for it. Okay, so why don't we, let me think. I'm going to erase this part over here. I'm going to erase these formulas. Okay. And let's finish the workout on the left-hand side. So I'm going to do a whole bunch of steps together. I'm going to try to consolidate this whole thing into one piece. All right. And then distribute. So 5.07. Let's take first, let's do sine of 22.5 divided by cosine 22.5. We get a value of 0.414. And then let's distribute that to these two terms, right? The 4.41 and the positive VB sine 18. So take that and multiply by 4.41. So we get a value of 1.83. 1.83. And then it's going to be minus now so we're going to take 0.4142, multiply it by sine 18. And we get a value of, it looks like just write this a little smaller here, minus 0.12828 VB, right? That's my variable. And then this is still, now I'm just going to write, then it's plus VB cosine of 18. So let's now add, since these are like terms, we can add these two together. So it becomes 5.07 equals 1.83. Okay. Negative 0.128 plus cosine of 18. This comes out now to be positive 0.823 VB. Now, how do I solve for VB? We'll subtract 1.83. Subtract 1.83. That cancels, right? So we got 5.07 minus 1.83. So this works out to be 3.24, and that is equal to 0.823 VB. Hooray! Just divide out the 0.823 now, right? 0.823. And finally, VB is equal to, my goodness, right? All for one problem. Divided by 0.823, we get a value of 3.94. 3.94. So this is the value of vector B. We found it. We found the magnitude of it. Hooray. So we got that. Now, how do we go about and solve for vector A? Well, what we now do, if you remember back to systems of equations, we can take this result, okay, hold on, this result, since it is equal to VB, I can take it and now plug it into either equation I like. I'm going to plug it into this equation for VB. And when I do that, I will only be left with VA. And then I can solve for it. So where should I do this? I have no room. So why don't we... All right, so why don't I erase all the work I just did, and we'll put it there. All right, so let's... Remember, it's 3.94. Okay, 3.94. So let's erase this all. Okay, that's the value. Actually, you know what? I'll leave that there. 3.94. Okay, so now let's rewrite this equation with the VB value in it. So we got 4.41 is equal to VA cosine of 22.5 plus now 3.94 times sine of 18. Okay, so let's just condense some things. 4.41. Why don't we find the cosine of 25 now? So cosine of 25 is equal to 0.9 0.906. So we got 0.906 VA, right? Plus 3.94 times sine of 18. So we got 1.22. Great. Subtract the 1.22 from both sides. Right? Let's do that in the calculator. 4.41 minus 1.22 comes out to be 3.19, 3.19, and that will equal now 0.906 VA. How do I solve VA? Great. Simply divide out now the 0.906. So VA now will equal 3.19 divided by 0.906. 3.52. So we got a value of 3.52. And now this is the value of VA. Okay, so let me put it, this is the value of VA, and we got our value for VB over here. And finally, that takes care of this answer. Hard problem, but hopefully it should make sense. Guys, thanks for tuning in. I know this was a long video, but I want to make sure you guys really understand the concepts. All right, so thank you so much for tuning in. Please, it would mean a ton to me if you were able to subscribe. And I'll see you guys next time.